photoelectric effect, which was detected by H. Hertz in 1887. In his experiment, he used metals like cesium or other alkali metals which are having low ionization energies are exposed to a beam of light. What happens? It starts emitting electrons, or it starts ejecting electrons from the metal surface. Ejecting electrons from the metal surface. Okay, so this is the experiment which contains a vacuum chamber, and this is the metal plate, okay, on which light radiations are fall. Okay, what happens? It starts ejecting electrons, and this was detected by using a detector which is attached to an ammeter, and the current flow is detected in the ammeter. So this is the experiment in which he used cesium or other alkali metals, because these are having low ionization energy. So these metals can easily eject electrons when they are exposed to a beam of light. So he used cesium or other alkali metals. And this phenomena is called as photoelectric effect. So what is called a photoelectric effect? The phenomenon in which photoelectric effect means the phenomenon in which ejection of electrons from metal surfaces when exposed to light radiations, okay, when exposed to light radiations of suitable frequency, okay, light radiations of suitable frequency strike on it, okay. This phenomena is called as photoelectric effect, okay. Okay. So the emitted electrons are called photoelectrons. Now, after this experiment, he observed some results. Okay, the results observed after this experiment were: first point, electrons are ejected from a metal only if the radiation falling on it is having a minimum frequency, and this frequency is called as threshold frequency. Okay, electrons are ejected from the metal surface, only if the radiation fall on it is having a minimum frequency. This minimum frequency is determined by nu zero. This frequency is called as threshold frequency. Okay. And the energy corresponding to this threshold frequency E is equal to h nu 0. Okay, this is represented by W0, and this energy is called as work function. Okay, so W0 is h nu 0. okay, which is called as the wave work function, okay, and which is the corresponding energy of the threshold frequency. This is the first point. Now, second point, the kinetic energy of electrons depends upon the frequency of incident radiation. The kinetic energy of the electrons emitted depends upon the frequency of incident radiation. Okay, next point. The kinetic energy of electrons depends upon the frequency of the incident radiation. Depends upon the frequency of incident radiation. Now, next point, third point. Number of electrons ejected depends upon the or proportional to the intensity of or brightness of light or the incident light. Okay. So, number of electrons ejected. Number of electrons ejected depends upon the or proportional to ejected is proportional to the intensity or brightness of light. Okay, intensity or brightness of light. So, third point. These are the different observations or result he obtained after the experiment. Okay, this is some of the results or results he observed after the experiment. Okay. So, in order to explain the photoelectric effect, Einstein modified Planck's quantum theory. Okay, Planck's quantum theory. So, according to his modified theory, first point, light consists of stream of particles called photons. Light consists of stream of particles called photons. Okay. Now, next point, when light of particular frequency falls on the metal surface, photon transfers its energy to the electrons of the metal atom. Okay. So, when light of particular frequency falls on it, that is falls on the metal surface. Okay. Frequency falls on the metal surface, what happens? Photons transfers its energy to the electrons. Okay, transfers its energy to the electrons. Okay, and also we know that the frequency of this light must be always greater than the threshold frequency. Then only the ejection of electrons takes place. Okay, of the energy to the electrons of the atom. Next point, then electron is removed from the metal surface if the frequency of photon is greater than the threshold frequency of the metal. Next, if nu is the frequency of incident radiation, then what will be the energy of the incident radiation? E is equal to h nu. Also we know the work function W is equal to h nu 0, which is the threshold frequency. So incident radiation must have h nu value greater than the h nu 0. Okay, so incident radiation must have energy greater than h nu 0. So what we can say, the excess energy obtained will be transferred to the electrons for their movement, or transferred as the kinetic energy of the electrons. Okay, so the difference between these two will be the kinetic energy of the electrons. Okay, so difference means h nu minus h nu 0 will be the energy transferred to the electrons for their movement. So we know the kinetic energy will be equal to half mv square. Okay, so this will be equal to h nu minus h nu 0, or we can say that h nu is equal to half mv square plus h nu 0, where m is the mass of electrons, because electrons are ejecting. So m is the mass of the electron, v is its velocity. Okay, half mv square is the kinetic energy of electrons. Okay, so also we can say that half mev square plus w0, which is the work function. Okay, now w0 is the work function of the metal. Okay, now let us do one problem. There is an important point about the photoelectric effect. That is, the threshold frequency depends upon the nature of the metals. That means different metals are having different threshold frequencies. Okay. Now, here the problem is, a photon of wavelength given 4 into 10 raised to minus 7 meter strikes on a metal surface. First point, calculate the kinetic energy of the emitted electron. That is, kinetic energy means the difference between the energy of radiation and the threshold energy. That is h nu minus h nu 0 we have to calculate. For that, first we have to calculate h nu. Now the second part is velocity of the photoelectron. Velocity means v. That is, from half mv square is the kinetic energy of the photoelectron. So from which we have to calculate v. Now let us do the problem. First part, kinetic energy. So for that, first we have to calculate E. E is equal to h nu. Lambda is given. So E is equal to h into c by lambda. So we know 6.626 into 10 raised to minus 34. H, Planck's constant is this much. Then C is 3 into 10 raised to 8 meter per second divided by lambda is given 4 into 10 raised to minus 7 meter. So after calculation, we get the value 4.97 into 10 raised to minus 19 energy. So it is joule. So this will be the value. Okay. Now h nu 0 is given, that is work function W0. W0 is equal to h nu 0 is given. This is equal to 2.13 electron volt. We have to convert it into joule. So 1 electron volt is given. So this is equal to 2.13 into 1.6 into 10 raised to minus 19 joule. So after the calculation, we will get the 3.408 into 10 raised to minus 19 joule. Okay, this will be the answer. Now we have to subtract these two, then we will get the kinetic energy of the emitted electron. So kinetic energy of the emitted electron equal h nu minus h nu 0. So 4.97 is equal to minus 3.408. Both are having same 10 raised to minus 19. So 10 raised to minus 19 joule. So what will be the value? 1.562 into 10 raised to minus 19 joule. This is the kinetic energy of the emitted electron. Okay. Now the second part is velocity of the photoelectron we have to calculate. Okay. Now the second part, so kinetic energy of emitted electron we already calculated, that is 1.562 into 10 raised to minus 19. So we know kinetic energy is half me v square. This is equal to 1.562 into 10 raised to minus 19. Okay, so we know Me is the mass of electron, that is 9.1 into 10 raised to minus 31 kilogram. So how can we calculate V square? V square is equal to 1.562 into 10 raised to minus 19. Me will come here, 9 point, so 2 will come up into 2. So 1 into 10 raised to minus 30. V square we will get. Raised to 34.3 into 10 raised to 10 will be V square. Okay, so V will be equal to root of 34.3 into 10 raised to 10. So root of this value 34.3 is 5.84 and 10 raised to 10 by 2 will be the root of 10 raised to 10. So 10 raised to 5. Velocity is in meter per second. This will be the value 5.84 into 10 raised to 5 meter per second. Okay.